Okay, I decided to go ahead and remove these 150s because I was seeing a little bit of funkiness on the screen I was seeing some missing dots and stuff. So I want to put these in my TI8662 tester, and I bet you these are bad. And I removed this. I found out what this chip is. It's an op amp. It's a 741. It's a LM741 that is in a 14-pin package. So what I did here was I just raised up the legs that don't matter and got the 8 pins that do matter in my tester, and this thing is an LM741. Tests good. So I turn it off and do a test. 741. So this op amp was actually good, but I wanted to test it anyway. And I can replace that with a 741. You just put an 8-pin socket in here and shift it down 2 pins, and you can use just a regular 8-pin 741. Those other legs are just not connected. So anywho, I'm going to go ahead, test these guys, put an 8-pin socket in here. I'll replace this, and I'm curious to see if these are any good at all. So I'm going to do that next. Alright, I got my leakage tester out, and I just removed a few of the green caps. And it looks like all of these green capacitors are bad. I have a nice new 0.1 microfarad decoupling cap on the tester right now. And it is the 0.1s are the ones out, the bigger ones out. The decoupling, that's decoupling. This one right here is good. You can see the light is out. You'll see how long it takes the light to go out. On a 0.1, it's about 5 seconds. 2, 3, 4, 5, 6, 7, 8. Okay, under 10 seconds for it to charge and quit leaking. If I take this old cap, 0.1, put it on, there we go. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we could count to infinity and this light will never go out. What does that mean? What this circuit does is it senses current across this cap. And if it senses current across the cap, the light stays on. Capacitors, there's no current direct current is not supposed to pass through a capacitor. This is leaking direct current from one plate to the other. That's what this is sensing. What does that mean? If all of these are leaky, just slightly leaky, it's going to draw more amperage from your power supply. What happens if these are leaky up in a sound section? Well, your sounds are going to be wrong. Or it could, and I've seen it in asteroids, it will kill the sound altogether. So I might have to recap all of these green caps. Yeah, see, that's still on. This thing is just leaky. Capacitors are not supposed to pass direct current through them once they're charged. So these caps are no good. You know, either they just will not charge up and stop charging. It's constantly passing direct current through it. So these things are no good. Over time, I guess they have just, the insulator inside of them has just broke down to where they will not insulate between the two plates. A capacitor is two metal plates with an insulator in between. In the insulator, it does exactly what it says. It insulates between the two plates. And if it doesn't insulate, then current's going to keep passing through it. So the insulator in these caps have broken down to where it's allowing current to pass through. So it's got to be these green caps. Because every one of the green caps that I've tested are bad. That's a 0.1. This is a 0.33 up here in this section. All right, bear with me a second. Okay. That's a 0.33, 0.033, or 33,000 picofarads. And you can see it just will not extinguish. Yeah. And you saw this is a 33,000 picofarad. This is a 100,000 picofarad, and you saw this took about 8 seconds for it to charge and quit passing current. It took about 8 seconds. So this is approximately 1/3 of the capacitance of this. So this is a 33,000 picofarad cap right here. This is the same value as that one. And this is a new one. So we'll put this one on the little leakage tester and see how long it takes for it to extinguish. And it's tough to do one-handed. Bear with me. Okay. Okay, we are on that cap, and you'll see how long it takes once I remove my finger. 1, 2, it's already extinguished. We'll do it again with the light off. Ready? Okay. 1, 2, 3-ish. And it's no longer passing current. So yeah, these caps are all bad. All of these green caps are degraded in such a way that they're no good. I tested these brown ones right here. The brown caps all seem to be okay. It's the green caps that are no good. And I'll spot check a couple more of these, but I think that they're all bad. I think every one of them is bad. So they really all need to be replaced. Because you're going to get excessive current draw on a power supply with these decoupling caps on the board, drawing extra current. So yeah, it's just not good. Caps are not supposed to pass direct current. If they do, they need to be replaced. So I think I'm going to go ahead. This company that made these green caps just did not use apparently did not use an insulator that would stand the test of time in constructing their caps. That's my guess. So I'm going to go ahead and just remove all of the green caps. And you can tell they're all by the same company because they have this little triangle up here. You know, they got little triangles up on it. It's all the same company. So I'm going to remove every one of them. Alright, I removed all of the big 0.1 decoupling caps from that memory board. Now this is another one of the boards, the second board in the stack, and I pulled one of the green 0.1 decouplers out, and I've had it on my tester for about a minute, and it's not extinguishing. So yeah, these are all leaky. They've got to go. So I'm going to remove every one of these ones too. I'm just kind of spot checking as I go, and so far they are all leaky. Alright, I have removed all of the decoupling caps on the 3-board stack. And I'm spot checking the very last one that I removed. I've had it on here for about a minute, and it is not turning off. So yeah, very leaky. You know what, I got to thinking, I remember on John's Arcade's video where John could not get a 3 amp rated power supply to work. It would die out on his board set. I bet you it was because of leaky decoupling caps causing excessive current draw, and that power supply could not handle it. I bet you that's what it was. Because he rebuilt his power supply, put a new old stock power supply on it, but it was a 3 amp rated power supply. And due to all of these leaky decoupling caps, I bet you it was just causing excessive current draw, and and that little power supply could not handle it. That is my guess. I removed every one of these, and they all leak. They're all leaky. As you can see, this one's still leaking. Yeah, so. Well, anyway, all of the green caps will be replaced. And this thing will be solid. Nice, solid decoupling. None of this leaky crap. So, alright. I'll probably have to order some 0.033 microfarad caps or 33,000 picofarad caps that are in that sound section. But I'll go ahead and do that. Yep. Alright. Well, I'll be back. Okay, I printed off a board layout of this, and realized that they used 0.2 microfarad caps as decoupling, not 0.1. So remember how the 0.1s, when I did them on the tester, took about 8 seconds to charge up and then stop leaking. So these in theory would be twice as long, right? So I've got some 0.22 microfarad, because I don't have 0.20 microfarad caps. But if I latch on to this 0.22, you'll see I've already done this test. It takes twice as long for it to charge up and quit leaking. There we go. Here we go. Watch. 1, 2, 3. Let me do that over. All right. And I'm letting go right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16-ish. Somewhere around 16, 15 seconds it charges and quits. So that makes sense. It's twice the capacitance of a 0.1. So these are all 0.2 microfarad, these decoupling caps. So they should take 15 seconds or so to charge and quit leaking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and we can just go on and on and on. It never extinguishes. So yeah, even though these are not, they are not 0.1s like I thought they were. They're 0.2. And I am replacing the decoupling with 0.1 because 0.1 is widely used as decoupling. So that is what I'm going to use. And I've already started, actually. I've got one of the boards done, I think. Yeah, this board's done. See all my 0.1 decouplers. Little yellow caps. And I ran out of caps, of course, so I had a few caps here that 22 nanofarad and 33 nanofarad there. So I had a few of them. Yeah. It's still on, still lit. Yeah. Okay. Very good. Well, I gotta order decoupling caps now. I'm all out of 0.1s. And I need to order some caps for up here. I need to order some 0.033s. And I'll make a list of other stuff that I need. Alright. We'll be back. Alright, and I am using my TI-8662 logic chip tester and testing those 74150s that are responsible with, in conjunction with that 74154 of drawing the, plotting out the dots for the rocket. And this guy is no good. It says failed, and you can scroll up and see where it failed. This one failed big time, failed a lot of the tests. Right there. Remember, pin 10 is the output. And so it failed a lot of those. And we can put another one in. Okay, and do this. And you see this one just fails one test. Pin 10 fails one test. And I remember on some of them I was missing one dot on the rocket. I remember that. And this is wrong in one spot, which is kind of, is that indicative of that? And this one is also no good. This one also fails one scenario way up here. So yeah, these are all no good. One of them's really super bad, and the other two are bad in just one scenario. So that would be missing one dot. Yeah. Which one was the really bad one? I think it was 3. Maybe. Nope. Maybe it's 2. Yeah. 2 is the one that's super bad. Yeah. Alright, yeah, so yeah, the rocket will never be shown right with those guys. They all got issues. 2 of them are almost good, and one of them's way bad. So, all right. Well, I did order some of these chips, so yeah. Test failed. Another great little tool, man. I love this TI-8662 for testing logic chips. It's awesome. So, yeah, I'll have to wait. I got a bunch of parts on order now. Now I'm just going to have to put the computer space aside, I believe, for a little bit. Wait for some parts to start coming in so that I can finish this thing. That'll do. All right, well, I decided to go ahead and poke around on this board because remember our saucer score, the middle score was going crazy. Remember that? And so what I did was I know, looking at the schematic, I know that this 93 here is what counts up that score. So I just wanted to look and see what is clocking that. And you see this pin 14 line right here coming down. It comes down, continues coming down, and it goes to this D3, which is a 7474, which I had already removed and socketed and tested it, and it tested good. Now it tests no good. Oh, now it's testing good. This thing's flaky, I believe. It was testing no good. Anyway, if I coin this thing up and start it, it's counting up, but without that 74 in there, it's not counting at all for the saucer. So I'm going to put a new 74 in there and see what happens. See if it counts crazy or if it counts normal. All right, and today is Saturday, the 4th? November the 4th, November the 3rd, November the 5th. Today is November the 5th. I got my order. I finished this with the diodes, and look how good this looks. All the new diodes. And I got these chips, and I tested all of these in my TI-8662, and they are all perfectly functioning. And they're nice ceramic packages. These are awesome chips. 74150 Texas Instruments ceramic package. Those are beautiful. So this board, other than the caps in the sound section, and I did order from Mauser Electronics, I ordered some caps. So yes, this is looking great. I'm doing a little work on this. I pulled some of the chips out of this and tested them. Some of them were bad. Some 76s were bad. And I think something else was bad. I don't remember. But I'm going to repopulate that. And this board is good to go. We don't have sounds. You know, we're going to be missing sounds, which is no big deal. I got to wait for the caps. But graphically and gameplay wise, we should be good to go. So that is where I'm going to be testing now. But I'm so super excited about how this came out. This looks awesome. So yeah, I'm waiting for the decoupling caps. I have to put decoupling back in this board. And sound caps. And this board is about half populated with decoupling. And I'm going to have to socket and repopulate this board. And it's looking good. All right. Let me go ahead and put this stuff back together, this guy back together, and we'll put the boards all in again. And give it a look-see. Okay. Well, you can see our little spaceship guy looks perfect. now. Our rocket. But this thing has sprung another leak. There's no motion now on the saucers. They don't move. You know, so yeah. Fix one thing, another thing breaks. But this board's looking good so far. Now I got a problem with the motion board. We're still not counting correctly. Let's start this thing. And this button right here is just messed up. This is a rotate left button. And if I mess around and tap on it enough, I'll stop rotating. See, there we go. Now it's doing that jazz. Yeah, this button is just janky. Thrust works. There's the missile fire. And I just hit him and it went to 1. That's good. Oops. Darn it. I gotta wait till I come back around and hit him again and see if it goes to 2. Alright, let's try to get him. 2. Alright. So our ship is counting properly. The saucer is not. Ooh, that went to 4. 3, 4. Not good. We get to go into extra play. There went to 5. Six. See my little thrust? I'm thrusting. You can see the little thrust tail. It's easier to see in the regular screen. Oh, I'm back to, I got back to rotating. This thing is jacked up. Yeah. It's almost counting right now. I found a bad LS20 on the very bottom board. I'm getting to where I just am, instead of analyzing or looking at these chips, I'm just removing them. Because it's a 50-50 throw up. They're either good or bad in this situation. And most of the time, they're bad. And 100% of the time, they're 50 years old. You know, and just, I don't know. I'm almost to the point where I just want to rebuild this set. It's just janky. Doesn't want to work right. So, but now I got to figure out the motion stuff, as well as the counting. The counting is better. It's almost the way it's supposed to be. And I think some of that counting is due to the bad motion board. So it's like a double whammy. Yeah, so I got to tackle the motion board. And I'll do that. Well, we're getting closer. I bet you some of those 161s on that motion board let go. Just quit. But, you know, never know. But this board's a success with the chips and the diodes for plotting out the spaceship, the rocket. That works great. So take that victory, build on that, and just move forward. Fix one thing at a time. Before you know it, we'll have every chip on this thing replaced. If that's what it takes, that's what it takes. All right. I'll be back. All right. I have come out, back out on Sunday now, to start looking at this again. And we are to where our saucers don't move. And I just probing around on this top memory board, and I'm convinced this board is good to go. Although this thing is, this one's doing, this is a 193, which is doing all, well, this 193 right here is an original 193 that's not really doing anything. I mean, it's not floating, so I'm not even sure what the inputs to this are. I'm going to have to pull the data sheet and find out what is what on this. I'm kind of convinced this is okay. Our problem is the motion board, saucer motion, and I'm going to have to get serious about analyzing those 16 counters, because those counters are the motions to everything on the screen. The rocket motion, the rocket missile, the saucer motions, and the saucer missiles are all on that motion board. So I need to really start poking around on that board and finding out what has died to cause our saucers to quit moving. So let me do that. I'm going to turn this off. I'm going to remove this board and start poking around on that middle board, the motion board. Well, our saucers are moving again, and this is kind of weird. So I had noticed that they quit moving after I did some work on the motion board. I pulled some chips off of the motion board to test. I put new chips in it, and all of a sudden it didn't work. Well, all I did to get this thing working again with the saucers, get the saucers flying around, was replace these two parts right here. They're 75s, 74, 75 flip-flops. Those two. In the ones that I had in the board, test good. But I replaced them with, I will show you. Let me grab my 75 75s. And this makes no sense. This is concerning. Some parts just don't work. These are the ones that I had in the board right here. And they test good on my tester. I had those two. I had two of these in the board, and it would not work. The saucers would not move. I replaced them with two of these. National Semiconductor 74LS75. And it started working again. So I think what I want to do is put these two back in the board again. And these test good on my TI 8662 Plus tester. Let's put these back in the board and see if our saucers move or not. Be right back. All right, these are the two that I just removed. and I put these two in the board. This one and this one. So I'll go ahead and put the memory board back in it, and then we'll check our saucers. Okay, we got our memory board back in. And our saucer is just not moving. It has just stopped moving. So those chips, these right here, even though they test good in my tester, they do not work in this board, and that is absolutely strange. I don't know what to make of that. Do I just throw all of these out and replace them with Texas Instruments parts? I can't trust these now. And the two that I put in are the same brand, the same ST. These are probably counterfeits. I don't know. Who knows what these are? But the two that I put in this time are the same. They're all the same brand, but it's two different chips, which test good in my tester, mind you. But they just don't work. They do not work. So, all right, I'll put these two back in it. I'll put these National Semiconductor. These are authentic parts right here. So I'll put those back in. And I don't know what I'm going to do here. I might just throw these all out. I don't know. I'll put them in a bag, and I'll put here I go. I got a bag right here. I'll put them all in a bag, and I'll put did not work in computer space. And then just put them away. I don't know. I can always try them in another board. Who knows? Anyway, let's go ahead and put those back in. This is the kind of stuff that'll set you back when you think you're putting good parts in, and this happens. Yeah. Okay, so I got the good 75s back in the board. Our saucers are moving around again. And I did put these in a bag with a note. Didn't work in computer space. I don't know if you can read that. I'm going to leave them in here in my 75 thing, my 75 bin, but I'm leaving them bagged with that note on them. So, all right, now let's move on. I just want to get all the controls right. And this control panel is so jacked up that it's hard to... I kind of almost need to make my own switches with these controls. You know, so those buttons are just not good. So I don't know. We'll have to figure something out. All right, I kind of came up with my own control panel. This one apparently you don't need. So I made one wire too many, obviously. But anyway, I have coin. This is game start. This is rotate right, RR. This is thrust, T. This is fire, F. And this one is rotate left. I am going to hot glue the contacts so that they don't short out on anything. But we're rolling. And I will set the camera up and do my controls. Basically, the way the controls work on this, the way that it's wired, is like conventional way of doing controls says it is normally open until you close it, right? You push the contact and it closes it and grounds it. That's how most games work. This one works the opposite. It's normally closed, and when you push the button, it opens the contact. So this is like the button not being pushed. It's in the center. which means this is closed. These two contacts are closed. The second that I do that, that's like pushing the button. So if you want to rotate right for a second, just do that, and then when you're done rotating, do that. You know, it's pretty simple. So I'll go ahead and set the camera up, and you'll see I've already done it. The controls are all working great. So I will go ahead and do that. It's still not counting right, though. This thing still does not count correctly. But we'll get to that. Okay, try to level this out a little bit, maybe. Okay, well, that'll do. Little zoom, little zoom. Okay. So I will go ahead and coin up and start. Okay, we are now starting. This is rotate right. You can see my rocket ship there floating around. Rotate right, stop. Okay, thrust. You can see the little thrust. Flame. Let's fire. I got a hit. Fire. Fire. They hit me. Fire. Okay, let's rotate left. And let's thrust. And rotate left and thrust. Rotate left and fire. Okay, you can see here's rotate right again. We're rotating to the right and stopping. Let's thrust, maybe. And game over. Cool though, you can see the controls work great. Not an issue. Yeah, my little makeshift control panel. And, you know, that's not my... Yeah, see, I have all these little things like that all hooked up like that. My job is the board. The control panel is not... That's not my concern, really. You know, the owner is going to have to source the buttons and fix all that stuff. But we need to figure out what's going on with that counting. That's been an issue. Yeah. Yeah, I don't know. We'll figure it out. We will figure it out. Okay. Very well. I'm going to look at the schematic a little bit. I'm going to study the counting circuit, the score circuit for both the rocket and the saucer. They're both not right. But the game counting is great. The game counting works great. It's just the scoring. Scoring is not right. So that's what I'm going to focus on next. Because we've got all the video right. We've got all the controls working right. Now we need to get the counting right, and then we'll move on to sound. So, you know, that's where we're at. I'll be back. This might be a good place to end part 3 of this video. And hopefully we'll finish it off with part 4. I'll be back.